Hi everyone, these are the guided notes for the Algebra 2 unit on functions, and this is for Wyatt in particular. We did some corrections and answered some questions when you were gone about the homework that was due for Wednesday. So I'm going to show you two of those problems and then do the guided notes for you. So let's get started. Someone asked about number 10. Because of this x squared, things look different. We weren't sure what it looked like, so I suggested that if you're not sure what a function looks like, you make a table of values and choose easy numbers to work with that you're going to plug in for x. So we chose 1, 2, 3, and 4. 0, 1, 2, 3, sorry, and 4. And we found that we got negative 5, negative 8, negative 9, negative 8, and negative 5. I'm just doing these from memory, but these are the outputs for y that you get when you plug in 0 through 4 for x. We saw, oh look, there's something's going on with these y values. There's some sort of pattern, but we weren't really sure what it was, so we decided to graph it and take a look at what it would look like. And what we found is that 0, negative 5, 1, negative 8, 2, negative 9, 3, negative 8, and 4, negative 5 ended up looking like a parabola. Because of that squared, it's a quadratic function. So before we even drew this, someone was able to say it is a function because none of the x values repeat. So yes, because we have no repeating x values. Now the domain of this function, how far left and right it goes, is all real numbers. You could also write it as all x's greater than negative infinity and less than positive infinity. You could also write it in interval notation, negative infinity to positive infinity. And then the range for this function is from its lowest y value up to its highest y value. The lowest y value is 9. The highest y value, well, it approaches infinity. And because 9 is included in the range, we have a bracket and a parenthesis around infinity. Okay, the second question that we talked about was this word problem. I'll do part A for you. We're given a statement, we're given a function that represents the commission made on the sale price of a car. And so Jack sold 2 cars last week for this amount of money. I believe this came out to $36,715. And so that, in this case, represents P, the price of the car, the purchase price of the car. And so we want to find his commission, P, based on how much he sold. What this means, this equation means, is that he made $250, even if he didn't sold anything and he sat around all day. His rate was 2 cents per every dollar that he worth of car that he sold. So we're going to plug in 36,715 for P. Multiply all that out, and we'll end up getting his commission. And I do not remember off the top of my head what that number is, but that is how this problem worked. In B, we're given C of P, $745.80. That's how much he made. So we're plugging that in for C of P for the commission in part B, and then just solving for P now, trying to find out how much he made. Okay, our next set of notes, these are the notes for this. What I did was just copy the homework for you so that it was less confusing. So while I scroll through, bear with me. Here we go. We've got standard and slope-intercept form for a line. We went over one of these. I think we did number 8 and wanted to make sure that we could get this in y, to solve for y, so we could get this in slope-intercept form. So we isolated y by subtracting 12x from both sides. Then we divided both sides by 8, and we got that y is equal to negative 12x over 8 plus 28 over 8. And when we reduced and simplified that, we got, we divide that by 4, negative 4 thirds x, sorry, 3 halves x. Negative 3 halves x plus 7 halves is equal to that's what the equation for our line. So we know that this is our b value, the y-intercept, so it's at 3.5. And then we know that this negative 3 over 2 is our slope. So we're going to go down 3 units and over 2, and up 3 units and over 2. There's our line. Oops. There's the equation, or excuse me, the graph of that line. So we just reviewed that. Someone asked about number 9 as well, but in the interest of time, I will not do number 9. It's the same idea, just solving for y and getting that in slope-intercept form, being able to graph that. Okay, we also took some notes on parallel and perpendicular in neither lines, and we talked about how parallel lines, of course, have to have the same slope, and how perpendicular lines have an opposite, we'll call it opposite reciprocal slope. For example, if the slope, like in the last problem, is negative 3/2, then its perpendicular slope would be positive 2/3. And so we did number 12 as an example and solve for y again. So we said negative 6y equals negative 9x minus 20, and divided everybody by 6, negative 6, and got that y is equal to 3/2 x. Let's see, divide both of those by 2, minus 10/3. And really what we're interested in here is just the slope. So now I'm taking negative 3y equals 2x minus 11 and dividing everybody by negative 3 and getting y equals, I'm not sure why that's not writing. Oh, there we go. Negative 2/3 plus 11/3. And it turns out that when you look at these two slopes, they are in fact opposite. They've been flipped over. Sorry, the sign is different, and the sign is different, and they've been flipped over. So in fact, these lines are, that's the symbol for perpendicular. All right, what I assigned for homework was the rest of this page, and it's finding the x and y intercepts. So I think, I'm not sure, I think I took 18, maybe because it looked a little tricky with fractions. And again, I'm solving for y, so in order to get rid of that 1/3, I decided to multiply everybody by 3. So I took 7/3 x minus 1/3 y equals 1. And when I multiplied everybody by 3, I got 7x minus y equals 3. So now solving for y, negative y equals negative 7x plus 3, divide by a negative, and y equals 7x minus 3. So in order to find the x and y intercepts here, you could graph the line. You could, you could certainly graph the line. Sometimes it's hard to tell exactly where on the line, where on the x and y axis the line crosses. This, I just realized, was a lot of work. Really, when we talk about x and y intercepts, that's where some line crosses the x or y axis, right? And so the y-intercept is always where x equals 0. So what I could have done here instead would have been faster, is to plug 0 in for x and solve for y that way. I could also do it with this equation. That's fine. It's a little bit more work or an extra step, but that's fine. And it's creating a new equation, but no big deal. So finding the y-intercept is somewhere on this line where all the x values equal 0. And so when I do that, I get that negative 1/3 y equals 1, and so y has got to be negative 3. So down here, I'll do it in a different color, down here where y equals negative 3 is where my y-intercept is going to be, and that's good because that's exactly what the slope-intercept form of the line told me. Now, if I want to find the x-intercept, if this was the y-intercept, then that's going to be along this line, the x-axis, where all of the y values equal 0. So I'm going to substitute in 0 for y and get 7/3x equals 1. And so the number that has to make x, the x has to be in order to make this true, is the reciprocal, so x is going to be equal to 3 over 7. And that is, let's see, a little bit less than 1/2. And so that's right here. So here is my line for that. I graphed by finding the x and y intercepts, which, to summarize, is plugging in 0 for x and 0 for y into two separate little problems to be able to find the intercepts and graph. Okay, I am skipping over the notes here and going straight to the homework section. So I didn't give you any of this. I also skipped linear regression in the packet and went to homework 4, I believe. Didn't take a quiz, so forgive me while I scroll through this. Let's see. Oops, did we do this? Yes, okay, we did systems of equations and solving by graphing. So I did not give notes on this. I asked everyone to work on their own on this because it's sort of a summary of everything we've been doing, getting something in slope-intercept form and graphing, or using x and y intercepts to be able to graph. And when we solve by graphing, we're actually finding the points of intersection. So identify the solution means identify the xy point that they have in common. Okay, I hope this has been helpful for you. Please reach out if you have questions, and I will see you on Monday.